All right. So, like I said, we're at the end of 10-4. Just a couple of word problems, and then we'll be done with that. All right. So we have a carpenter. He cut a 6-foot board in 2 pieces. One piece must be 3 times as long as the other. Find the length of each piece. All right. So if I just did I guess a diagram of what we're doing here. It's cut into 2 pieces. The board itself, 6 feet long. All right. So we need to set up our 2 pieces. Those are unknowns. We have 2 pieces of board. So what we can do is that we can call one of them X, right? And then the other one has to be 3 times as long as the other. So we can call the other one 3X. All right. Questions on the setup? So now if we look at the diagram, we have 2 pieces of board, and when I put them together, they total out to give me 6 feet. So I can create the equation of X plus 3X is equal to 6. Questions on the setup? All right. Add them together. That'll be, you can go ahead and solve once you have your equation set up. Add them together. That'll be 4X. Excuse me. And we can take that, divide it by 4. 4's cancel on the left. X is equal to 1.5. Now, on that last step, remember I said you need to always go back and check and make sure that you actually answered the question. So here it tells us to find the length of each piece. So if you only type in 1.5, of course you would be wrong because you need the answer for both pieces. So we know X is equal to 1.5, which is the short piece, and then 3X, 3 times that 1.5 is 4.5. Or you could have taken that 1.5 and subtracted it from 6. Still would have given you 4.5. All right, so you got your short piece and your longer piece. All right. questions. All right, one more like that. All right, in a recent Olympics, the U.S. won the greatest number of overall medals, followed by China. The U.S. won 16 more medals than China, and together they brought home a total of 192 medals. How many did each country win? All right. So first, we have our two unknowns. We have the U.S. and we have China. So the U.S. won the greatest number of medals, followed by China. U.S. won 16 more than China. So what we can do is that we can call, since the U.S. number is given in terms of China, we can call China X and then call U.S. X plus 16. All right. So we know totally when we add our medals together, add up US and China, it equals to 192 medals. So what I would do is do X plus 16, which is the US, plus X, that's China. And if I can make it look decent. When you add them up, that's equal to 192. And that's our equation. Questions? Any questions before we solve it? All right, those parentheses are just there just to signify that this is from the United States, this is from China. So I can go ahead and just add my like terms. X and X would be 2X 16 equal to 192. From there, subtract 16. Two x is equal to 176. Divide by 2. And that's 88. X is equal to 88. Once again, they didn't ask us just for one. They asked us for each. So X is equal to 88. You can go back. That means China had 88 metals. And then 88 plus 16 will give us 104. Or we could have taken that 88, subtracted it from 192, still get that 104. All right, so questions before we go into solving inequalities. I think I may have already written these up. Give me a second. Let me see something. No. I'm looking for. Yeah, let's do this. Okay, hold on. It says 4.5. And this right here is just a note for myself because I've already written these notes up. So it'll be easier if I go through them instead of rewriting them. Take up less time. And I believe it's 4.5. All right, so this isn't 4.7 for us. This is actually 10.8. So like I said, I had some old notes that I written up before. And so it'll be easier, take up less time with me trying to rewrite all the stuff when we can just go off of my older notes. Same stuff, math doesn't change, so we'll be all right. So solving linear inequalities, 10.8. So a linear equation is what we've dealt with up to this point. 2x plus 5 equal to 7 is an equation. A linear inequality, 2x plus 5 is greater than 7. So the first difference that we have between the two is that an equation has an equal sign and inequality has your inequality symbols. Okay? So equation has an equal sign, inequalities have your inequality symbols. Now when you solve, you're going to have one solution for the linear equation. For your linear inequality, you have infinitely many solutions. Or in other words, a solution set. So infinitely many solutions, you have a solution set. So when I go to solve this, you're going to solve it the same way in both cases. You're going to subtract 5 from both sides and divide by 2. Here, I will get x equal to 1. So that's only one solution. Here, I get x is greater than 1. So what will work for this inequality are all values greater than 1. Those will be your solutions. So you're talking about 1.5, talking about 3, 10, 100, 1 million. any value that's greater than 1 will be a solution for this inequality right here. And 1 is not a part of the solution set because we want all of the values greater than 1. All right, questions? So we will solve. You'll get only one solution when you're dealing with equations, a linear equation. But if you have a linear inequality, you have infinitely many solutions. You have a solution set. A solution set. All right. And here I'm just going through the process. If I have 2x plus 5 is greater than 7, just like before, subtract 5 from both sides. 5's cancel. You're left with 2x is greater than 2. Divide by 2. And x is greater than 1. So that's where, we got that from. All right. Always, as always, let me know if I'm scrolling up and you need me to slow down or something. All right, your inequality symbols. We have less than or equal to, greater than or equal to. So here we're just comparing the difference between having your regular inequality and or equal to. So you're talking about greater than versus greater than equal to. When you have that bar under it, that includes your value. So in other words, if I have x is greater than 2, I'm saying that my solutions will be all of the values greater than 2. That means 2 is not a part of the solution set. But once I put a bar under the greater than symbol, that's greater than or equal to, so that's telling me I want 2 to be a part of my solution set. That says all values greater than or equal to 2. That means 2 is a part of the solution set. All right. All right, the other part of our answer, right, other part that we have to consider is interval notation. Less than and greater than, you will have parentheses, which means exclude. That goes back to what we were talking about here. We're not going to use that value, so parentheses will reflect the fact that you use less than or greater than. Less than or equal to, greater than or equal to means include. And once again, that goes back to what we just finished talking about. Then we have negative infinity and positive infinity. And you will always use parentheses on your infinity signs because you can never include infinity.
Wait, can you repeat that?
You will always use parentheses. These right here, you'll always use parentheses. That's what I was saying right here. That's why I said always use on your infinity signs. So whenever you see an infinity sign that you have to use, you will always use parentheses on them
Okay.
because you can never include infinity. You can always go to the next value. The only time you use brackets is when you're trying to include the value as a part of your solution set.
Thank you.
No problem. About being that are greater than 2, so you're going from 2 to infinity. Your parentheses on the 2. We're going to infinity, we'll use parentheses as well. Here, because we have the or equal to symbol, we're going to use bracket, but we still use parentheses on that infinity sign. Questions? Any questions? Make sure we're all right. I'm going to give a chart that reflects all of this as well. So just laying the foundation right now. Now, if I had to graph both of those, your interval notation, which is up here, needs to reflect what's going on in your graph. So if we're going from 2 to infinity, that means we're going from 2 and we're shading to the right. And that arrow right here represents positive infinity. So we use the parentheses just like we used in the initial interval notation. Parentheses, shade to the right. And the parentheses will be over your 2. And then use the bracket for the or equal to symbol, shading to the right, because we're going to positive infinity. All right. Questions? Any questions? All right, so let's look at this chart. Just going to show generically all of your scenarios that would occur. Don't forget, I don't think I pointed this out. When you look at your number line, just generically at your number line, zeros in the middle, 1 positive, 1, 2, 3, 4, all the way to the right, negative 1, 2, 3, and so on, or to the left, all your negative values to the left. No matter what your number you're looking at, let's say if we look at positive 1, all the values to the right of positive 1 are greater than it. All the values to the left of positive 1 are less than it. If I look at negative 2, all of the values that are greater than negative 2 will be to the right of it. All of the values that are less than negative 2 will be to the left of it. So when we go to this chart and we have A and B just generically, it does not matter what A and B are. They're just real numbers. And if I want all the values that are greater than A, that will always be to the right of A. And if I want all of the values that are less than A, that will always be to the left of A. So no matter what your number is, that will always be the case. So if I solve down and had a solution set of x is greater than A, same thing like I had up here, x is greater than 2, same format. I would be going from A to infinity. So as far as my interval notation is concerned, that's A comma infinity. I will use parentheses because I'm using the greater than symbol. And then parentheses on my infinity sign because that's always the case. When I go to my graph, I will go from A to infinity. So I'm shading to the right using my parentheses. Each piece should reflect, what's going on in the other piece. So if I use parentheses in interval notation, I should be using parentheses in my bracket and so on. Second row, same relationship, except I have or equal to. So I will use bracket and then shake to the right. Next one, we're looking at less than. X is less than A and less than equal to A. So I'm coming from negative infinity to A. You always write the least value or the smallest value first. So we're talking about coming from the left, which is negative infinity up to A. And so this negative infinity comma A, use parentheses. And then my shading will be from A to the left, to that left arrow, still using parentheses. And the next one, that fourth row, is or equal to. So it's still the same shading, it's just that we're using brackets. So questions on that, on the first four. All right, so the next four have three-part inequalities. Notice X is in the middle, and this says X is greater than A but less than B. So the values that are greater than A but less than B are in between A and B. So notice both of our symbols less than, so we're using parentheses, and then we shade in between. The next one has the or equal to attached to the A, but not B, so you use bracket on A, parentheses on B. On the third one, you switch them, so that's parentheses on A, bracket on B, and then on that final one, both of them have or equal to symbols, so that'll be bracket on both. And then, as I said before, your shading will reflect the same in each, and so would your symbolism. So your brackets and parentheses will be in the same spot on each case. I guess it should say respectively, according to the brackets and the parentheses that you used previous. Any questions? All right, so we're going to solve these inequalities the same way we would our equations, except for one thing that we have to consider whenever solving inequalities, and that's this: when solving inequalities, and you have to multiply or divide by a negative number, then you must change or flip the inequality symbol. Let's finish writing that first. So if I start off with the inequality of negative 3x is greater than 5, I would solve by dividing both sides by negative 3. And what would happen is that at some point, when I come down to my final answer, I need to flip my fraction from greater than to less than. And that'll be a negative 5 over 3. So x is less than negative 5 over 3. So that's what we mean by that. If you have to divide or multiply by a negative value, then you have to change your inequality. And then if you had to give the other two pieces, talking about all the values that are less than negative 5/3. So you can put negative 5/3 generically in the middle, use parentheses, and shade to the left all the values that are less than negative 5/3. And then my interval notation needs to reflect the same way, negative infinity to negative 5/3, parentheses on both. All right. So let's look at an actual equation. Do a few of those, and then that'll be it for that section. So we handle it the same way we would if we had this and there was an equal sign there. 5x minus 6, excuse me, is greater than 4x plus 2. So we can subtract 4x from both sides. Your goal should be to get all of your x terms to one side, all of your terms without x to the other. So that'll give me x minus 6 is greater than 2. Then I'll add 6 to both sides. X would be greater than 8. The other two pieces that come along with that, you want the values that are greater than 8. So you're talking about 8 and shading to the right, using parentheses over the 8. And then as far as your interval notation, that's 8 comma positive infinity, parentheses on both. All right. All right, looking at the next one. Negative 5x minus 3 is less than or equal to 12. First thing we'll do is add 3. That'll cancel on the left. Leave me with negative 5x is less than or equal to 15. Divide by negative 5. And that will be x is greater than negative 3. Don't forget this has to change because we divided by negative. All right. So you want the values that are greater than or equal to negative 3. Greater than means to the right. So you shade to the right of negative 3 using bracket because of that or equal to symbol. And then negative 3 to positive infinity would be your interval notation. Once again, use a bracket for your negative 3, but then parentheses over your infinity sign. And these processes are the same that you follow as far as solving, the same that you follow that when you're solving linear equations. The only extra piece is the fact that when you divide by negative, you have to change your inequality sign. Other than that, adding 3, dividing by negative should be should be a review for you guys. Right. So now this next one is called a 3-part inequality. And this is the setup for those last 4 rows in the chart. So if you remember those last four rows in the chart, the goal was to, well, what they had was a number inequality, then X in the middle, and then another inequality in the number. So our goal should be to keep X in the middle when we go about solving. So if I want to solve for X and I have 2X plus 1, my first move is to subtract 1. So if I subtract 1 from the middle, then I need to subtract 1 from all three pieces. And the ones cancel in the middle. And what we have is -4 less than or equal to 2x, which is less than 6. All right. Then from there, still trying to get x by itself, so we'll divide by 2. 2 is still in the middle. That leaves me with -2 on the outside and 3 on the other side. So I want the values that are in between -2 and 3. And that's how it would look as far as my shading is concerned. Bracket over the 2, parentheses over the 3. And then my interval notation, that same reflection should be shown. I'm going from -2 to 3. So -2 comma 3, bracket over the 2, and then parentheses over the 3. See any more? Okay. Questions. Questions.
So,
Sounds good. Thank you for responding. Anybody want to see another one? Are we good? Y'all talk to me. Are we straight?
I think I'm good.
Say that again. A little low.
I think I'm okay.
Okay, cool. Well, that's like I said, that's the foundation of solving linear inequalities. Any type of problem that you see as far as complexity is concerned is the same level of complexity you will see solving your equations out of, I think, like 10.3, 10.4, one of those, 10.2, 10.3. So next class, I will open the floor for questions first. So if you have any questions out of chapter 10 or any chapters actually, but if you have any questions, especially out of chapter 10, since we're just coming out of chapter 10, I will address those first. If no one has anything and everybody seems like they're doing all right, then we'll go ahead and get into chapter 11. See how many more chapters we have here. Still got a little ways to go, but we're on a decent pace. But we will go get into chapter 11. Only 3 sections out of chapter 11. Okay. Only 3 sections of chapter 11. So outside of that, have a great weekend. Be safe. And
You too.
I will see you on Tuesday.
Thank you. You too.
All right. Thank you.